All right, the time has come to assemble the motor back in the unit. So I'm starting with the mounting rubbers. So what I have discovered here that these rubbers are slightly thinner than what the original should be. And I'll show you that, why I say this. Okay. So if you can see, when you put the washer on top, okay, you put the screw there, you could see that once you put the bottom washer, okay, you should see there the shank of the bolt, okay, that there's going to be some movement there, little movement, because the rubber is not thick enough. Now, this may be why 4 old washers was given with the new rubbers, but they are useless. Why is that? Because this bolt has 2 sizes. Okay, it has the shank part, which is wider than the thread part. Okay, and this is what you call really is done as a spacer, so you don't squash fully the rubber. Okay, otherwise you will over tighten, not over tighten, but you squashing the rubber too much until it stops. So the idea is to squash it a little bit and then it will stop, because it will bottom out. But if they wanted to supply washers, they should have supplied the wider hole washer, because you can put as many million washers you want. Okay, in the bottom, this washer only fit in the bottom, and it's not going to make a difference because the distance is between that point. Okay, so if you want to shorten the distance because the rubber is not wide enough, then you need the bigger washer. Okay, so what I had to do is I had to look in my old compartment where I keep old washers. Not going to try to order new ones. So I will be putting the original washer first, because it fits tight on the shank, and then that. And that means that this rubber is going to be squashed the thickness of that washer. And that needs it, otherwise you got no pressure at all on the rubber, and you should, because that will help as well the screw, okay, and the motor not to move and to be actually on the washers, on the rubber, because the way it is, if I don't put that washer, the bolt is too long, because the rubber should have been a bit wider. So that's that. So I will install these rubbers and we'll continue on. All right, the time has come to fit the drive gear, and I removed the brushes, so when I'm hammering it's not going to chip the brush maybe. I have tried the gear here, and by the time you get it where the hole needs to be, it's slightly sort of a bit loose, so I'm gonna put a little bit of this, and I'm gonna do that on the edge, so it's about there. Okay, so the edge will be about there. Okay. Spin this. I think the factory have put this as well, because you don't want to rely 100% on the roll pin. Okay, so just need to make sure it's on the right spot. Make sure that's right there. And the roll pin. Now let me get a punch again. Because I don't want to be hitting the gear. You can go a bit more. Okay, so I'll have that facing down to make sure the retaining compound doesn't go in where the bush is, and we'll just spin it as well. But anyway, I'll let that dry up. Okay, so I actually removed the latch from the screws, so I don't want to be, don't want to be removing the pin on that again. So we have the motor here, and last look, that's how it is. Okay, and it's ready to put in. So the rubbers are changed, the mounting rubbers, and this will fit in like this. So I've realized that this washer here, I didn't put it in. So what I'm going to do, I'm going to apply, come on, I'm going to apply a bit of super glue, very light, onto the washer, so it will get stuck on the rubber and will not move about, and then I'll drop the motor back in. So that's what I'm going to be doing. So I'll do just a drop of super glue there, just 2 drops is enough, and I'll put that in, and as a guide there. So there you go, that's stuck. So I'll do the rest. Just show one more. Just a tiny 2 drops, and okay, so I'll do the rest. Okay, bit of a learning curve here. The best way to drop this in is to have the screws already in the mounting rubbers. Otherwise you can't put your hand in there. So that's what I'm doing. Drop it in slowly with the screws. Okay, now a matter of finding the correct location. That's it, threading. That one too. That one too. And the last one here. That one too. Okay. So let me pause it so I can have a good look to make sure it's aligned right, and I'll tighten the screws. Okay, so the motor is back in, and believe it or not, I still had to take that latch off because after fitting it, that latch was behind the motor. And actually, I've realized there's no way of doing it without completely taking it off, at least from this side. I originally took it off from the top when I was fitting it, and that can never work out, so you need to remove it from the bottom. So there's no way of getting away with that. And what I did, these screws, I undone them because these screws, okay, they are designed to align the motor and tension the belt once we have the gearbox on. So I really want to re-tension that, because it could have been that it had too much tension on it, you know, and we're wearing out the bushes. So the bottom 4 screws that holds the motor on the rubber mounts, they're not fully tight. They are just in and left slightly a bit loose. So when I adjust on top of here, they can relax to fit, you know, once this angle is right here, once the tension of the belt is right. Once that's right, then I'll fully tighten the bottom 4 screws. So that's my plan. So that's what I'm doing. Okay, so I'm going to fit the gearbox in. I'm going to start with the threaded bottom screws first, as it's easier to mount. And then I'll put the top ones in. Now the top ones are these ones. So we had a bolt, and you see I have to slightly unloosen them. So we're able to run the top bolt in. Screw. It's sort of built like a bolt. For some reason. And it needs a little tap. Funny enough, I see 2 little marks there, and I don't see them on the other side. Just wondering if somebody tapped them as well from the factory. I'll move the camera this way. This was always the 8mm, very tight, because assuming it's probably not 8mm. I don't think that's going to come off. Okay, now I tighten the bottom ones. Okay, so that is the gearbox in. So I'll spin it the other way. That's it. So the belt goes here, and of course it's loose because I backed off these screws, so that's why the motor bottom bolts I left them a bit loose, so we'll be able to adjust this. So, but let me just inspect the belt, because I actually haven't done that. Okay, so I fitted back the belt, and probably does really need changing, but I'm not going to change it because I already spent enough money on it, and it's going to be too much. If it breaks, then we'll change it. Those rubbers alone for the motor, they were actually $25, so not cheap. So now I have to adjust the motor back up, and it has to be pushed back. You can see the belt pulling. It can go a bit more back. I'm trying to do it evenly. Quarter of a turn each time, or a bit less than quarter actually. So it still needs a bit more. You don't want it too tight because it's extra pressure on the bush. We'll see how that goes, and we'll try that once we connect the wires, because I haven't connected the wires yet on the motor. To fit this cover on, I didn't show it, but was a boring thing. I had to actually take the latch off because I couldn't fit it. The cord here is very cool. It's got a cut here, and it's sort of a bit worn out. I mean, I was thinking of cutting it and just losing, you know. I was going to measure this. It's about 200 mil from where it's tightened. Is to start again and just do a new, and that's what I'm going to do. So I'm going to cut it here and just run a new section. Okay. Have to see how this went. So I'll strip the wire here and I'll do a new terminal thing on it. Okay, so the terminal is fit back in the unit there, and we've got to feed the wire, which I cut this much of it here, and I'm going to redo it. And these terminals, originally they made that you twist the wire around and tighten the screw. It's got a copper holder there, sort of special couple of washers. But I thought, I've got these and I'll be fitting this. But what I do with this is I take the insulator off. These are auto plugs, but there's no rule to say you can't use them for this. So what I do is I'll hold the terminal like that, and with the other pliers I remove by twisting it, and we'll put these in here. Okay. And we'll give them a bit of a squash just with the pliers. See, I do have a crimper. Just crimp it so it holds a little bit, but it's not relying on the crimp. And it will rely on the solder. So got a problem with the soldering iron at the moment. Okay, so I'll just solder these. Just straighten this. That's okay. Actually, what I normally do is put some heat shrink as well, but I won't be doing it now. Okay. So, this wire is a bit sort of stiff, but we'll see how we're going to do that. I got the neutral on the left. Need to twist the wire a little bit. So use my hand in the way. So I couldn't film with my hand in the way, but there the terminals in there. So I've done it in that way. Okay. And so now it's a matter of fitting the cover back on there. Okay, so I put the cover back. Again, my hand in the way cannot really film properly, so and now putting the wire holder support, and it's also okay, so that's tight, and I'll just tighten these as well, but I've already tightened them. They don't have to be too tight, otherwise it'll squash the wire too much. Maybe, yeah. So that's that. Now if anybody is interested in this old wire here, I'll just strip a bit of it. I don't think they make wire like this anymore. But this wire have two sheets. It has a clot sort of thread on there. Okay. Material, and then it's got a couple of ropes as well inside. So that's how they made it. And this is made of many strands. So that's how they supported the wire to make it strong. Obviously today's appliance, they don't have anything like that. But yeah, it's double insulated, so that's why it hasn't got an earth and all that. I sort of missed that originally at the beginning of the videos. I didn't see that, but anyway. Even though the frame is metal. So now I need to put the 4 screws that holds this cover, and then we can test it. So the 4 screws is here. And we'll fit the back ones. And around here I had to actually adjust the wire again, and probably now, just thinking, it makes sense why they used the rope inside, because here when you open it, it changes, so it's moving the wire. Okay, when you open and close this, you see the wire moves. So I suppose that it's why it's designed like that, and I think this wire is gone a bit brittle as well. because I noticed where I squashed it here underneath the clamp, the insulation of the white here already started to cut again. So one more test. Yeah, there's nothing much you can do with that. Maybe I'll give it a bit more, but if you give it too much it might kink more. There's no way around it, that's how it was, so it has to be that way. Maybe this one will angle this a little bit. That way. Okay. Okay, so I have tensioned the belt here, and so you know how I said originally I unloosened them when I fitted the motor. I unloosened the screws here, the 3 screws, backed them off, and then what I did is I put the belt and I tensioned it. If you recall, I mentioned that, maybe showed a little bit of that, and slowly, evenly make sure the motor's still centralized. You can't be too far off because it's got the 4 mounts, the 4 rubber mounts, okay? And as a general rule, what I know is these type of timing belts, when you tension them, is when you twist them, you still can do a quarter turn. So let's see if I can zoom in on that. So once you tension it, this should still do a quarter turn like that. If it cannot do a quarter turn, then it's too tight. Okay, so as you can see, that's just a quarter turn. So it does feel like a little bit sort of like loose like that, but the timing belt is not a belt where it relies on pressure. It's got the teeth to grip. So that's that. And once I did that, of course, I fully tightened the rubber mounts screws, the 4, okay, and just done the last retension if I needed a little bit of adjustment again, okay, in the belts. Because then what I did, I actually spun it. So we're going to give it a test here, just to see, okay. So that's on low speed. So the gearbox not turning because this pin's not in. So that's low speed. That's maximum. And you can see the belt looks okay when it's running. Okay. A little bit of a vibration there. Full speed. Also, the unit is not on a rubber feet yet, which is important, of course, as I said, to be able to let the air in underneath, but we're not running it for a long time. So that's that. Now, I did want to as well test so we'll press this down to get the gearbox turning. You can see here, and you can see the belt's still alright. Maximum. Okay, so that seems to be fine. And another thing I wanted to mention, so I have the unit here. Let me show. So I have the unit here plugged in to my variable power supply, which is a Variac, and so it's set at 240 volts, and at low speed you can see that's the bit of a erratic change there, and it's those points running right now. Remember, now we have the triac running, so it's not relying on that arcing being the points having the arcs there. So there's no arcs, but the contacts of the points still might, you know, bounce a little bit, and you always got that little erratic there. But that's much better than what it used to be. But the other thing that I did, and I did this off camera because I found out later when I tried it, is remember the governor and the motor, and it's had that Allen key grub screw that locks the governor, and then the governor pushes against the switch. I found if the backlash, so you see the backlash in the motor when you go up and down, now it's hardly got anything. It had maybe half a mil. Yeah, it's too much. Half a mil is slightly too much. So it's slightly a bit less than that. You don't want it too tight, but if you have the backlash too much on the shaft of the motor where it could go up and down, then the points might run a bit more erratic, because little vibration there and there on the shaft going up and down, when the contact starts to open and close, okay, it might be touching and not touching, okay, because while the motor is vibrating, well, you get little vibration, you can hear it, but you can't really see it. So I found the smaller the clearance on the backlash of the motor, the better those contacts will work. So that's what I've discovered with that. It did enter my mind at the time, but I thought I'd better give it a bit more, but it still had too much. So since I've done that adjustment again on the governor, I made it a bit more, because it control where the grub screw is, it takes away the backlash of the where those shims are. And remember, now the motor's upside down. Okay, before I was running it sort of the other way around, 180 degrees. The less clearance it has, the better the low speed control is, less erratic. And of course you can't have it too tight, because then it might be, there's no room for expansion there or anything on, when it gets a bit hot. So yeah, so at full power, it actually draws 0.82 or 0.8 there of an amp. Okay, and then we'll check once I have the whole machine assembled and I can run the gearbox properly. We'll see how much extra wattage it will take with the full gearbox running. All right, here at the front, it's supposed to have some sort of gasket, and what I had of the original looks like some sort of very thin fiber material washer which went around there. So that's perished, but I found a bit of leather. It was a smaller hole. I cut it with the knife and just sanded it, so it's some sort of leather, and I'm going to be putting this here. And this is going to be a lot stronger, and I think will last longer than what they had before. So that's what we got now. Okay, there. So that's what I'm going to put. The only thing I'm not sure, because I don't have the attachment on the front, see it's got a cut here. If that will affect anything, it might be maybe a bit thicker than the original. But I will have to check that when I have that attachment. And besides the felt that needs to go underneath for the bottom cover, on the top here is supposed to have another piece of felt that goes over here. So when you put that section on, this by the way comes off, it will fit some sort of seal there, and any vibrations sort of been taken away. So that didn't have it on there. So I'm convinced that somebody have worked on this machine before. But anyway, I have some felt here material, or if it's not felt, it's similar to this. It's made out of sort of fibers. So I've measured a hole here with a texter and marked it, and I'm just going to cut it with the scissors. Okay, so I've got a bit of a hole there. Just bended it over first and just cut a small hole like that, create a hole, and then went inside and just went around with the scissors. Nothing special, but that fits there. So that will be the top felt for that. So we'll just try this. Zoom out. Okay, so that's that. And I will try this. Just put the screw there. I'll just give it just an experimental test here. So we'll need to put the top. Give it a go. Slow speed. Okay. The only part that I thought I'm not really happy about is, see if I can zoom in. Is the gap that you see here. Okay, this is 2 mil shorter than the original. On the original hub, this hub, as you can see, it's a lot, it's 2 mil bigger. And with this, the gap is much smaller here. Which to me, the person I bought it from thinks that this shouldn't make a difference. Well, it doesn't for operation. But in the long run, this will make a difference, and the difference will be that the flour, if you're baking dough, you're making a cake and you got flour in the mixing bowl, dust of the flour could fly eventually. It starts getting into here. Yes, this has got a cover. It's still a bottom cover here that needs to go on, but and covers this up to that point, halfway on this, the bottom cover. but it's still got a gap, yeah? So really, ideally, is that the cap shouldn't be too big, and I believe that it will be better in the long run. But I have an idea what to do here. So I've got this cloth tape here. It's electrical cloth tape, and I've cut a piece here. And what I'm going to do is I'm going to attach that to there. All right, and not to grip to here. Okay, what I'm going to do is, or try, is I'm going to run an extra line of tape here from the other end. So it's getting rid of the stickiness of the tape, so it cannot get caught on the hub. And being a cloth tape, it can sort of take some little wear running on it. I'm going to try that and see if that will work okay. So that's my what I'm thinking of doing, just to seal that for future, right? And it's only a cloth tape, so even if it gets caught and rips off, nothing dramatically is going to happen. Though with the cover on, this of course, it's got the cover, but let me pause it. And so I put it upside down, and we have the cover here, and the cover fits like that. Okay, and if I try that upside down, it's got, of course, a gap around this. We'll have to see. My idea might not work, because it might interfere. Though it is very thin, I don't know if that will get make it too tight with the cover. Anyway, we'll try it. If it doesn't work, then I'll have to throw away this idea. Okay, the other thing that I wanted to check is that in the instructions it says that this should do 60 RPMs, okay, 60 revolutions per minute. So I just want it on low speed. So I wanted to see if that's that. So I got a stopwatch here. So that's counting, right? 1, 2, 3, 4, 5, 6. Okay. So I'm going to start when I press 1. I'm going to press the stopwatch. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 118, 119, 120, 121, 122, 1 Okay, so it looks like it's doing double the speed because I counted 60, 50 and 10, and I've got 34 seconds. So I'll have to adjust the bottom, those two little screws where the springs are. So it's running too fast. So let's see if I could slow down that. Alright, so I've got the machine upside down, and to slow it down, I'm pretty sure you undo it. So we'll do half a turn each time. So let's put a mark here. Actually, undoing it was going faster, so I gotta screw it in. Half a turn. Have to find the other screw. Okay. Which is not easy to do, and I need to get the camera out of the way to do that, and I need more lights. Start again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Okay, so I counted 30 and I've got 27.76 seconds. Now the instruction manual also says that it's plus 60 RPM plus or minus 5 revolutions. So it should have counted 27, okay, to be spot on. Now, because I'm only going by 30 seconds instead of 60 for the 1 minute, it almost counted 28, because 27.7, okay? 27.7. So let's say it counted 28, okay? It means it's for the 30, it's 2 revolutions extra counted. So for the in 60 seconds, okay, it would have counted 4 extra. Now the instruction says plus or minus 5 counts, 5 revolutions per minute. So it's okay. It's slightly fast, okay? It's actually counting 4 revolution extra per minute. 4.5, something like that, okay? 4.3 or 4.2. So it's quite good. Probably I don't want to really slow it down any more than that, because that's running with no load. It is very slow. So I think that's fine like that. And as you can see now, if you remember the first footage, the first episode, you could see this was going like that, because the original hub, when it turned, was running on an angle. This runs pretty much straight, as you can see. So that's good. That's the play in the gears there. I mean, ideally is that gear here should have needed to be changed. Of course, you can't buy that, and you can't really buy a new gearbox anyway, but you can buy a second-hand one. But we'll see how it goes like that. So that's that part. Now I've got the machine upside down, and if you remember the knob, the edge of that, where you see there, the flat part, used to rub on this section, on the surface of, so inside there, okay, the flat part there used to rub on this, on there. As you can see now, I mean, I didn't really have to show this, but okay, it's got heaps of clearance. It cannot rub. Okay, that's in the off position. Okay, you can see that it's got, I don't know, by 4 mil, 5 mil, maybe even more. Okay, that used to rub the plate, and that's probably why the knob was broken, because while that was getting locked there, they were forcing the knob more to turn it, and they snapped it. And I suspect that maybe someone did file that latch to create a bigger gap here so the knob doesn't rub. Okay, I think that's what happened there. Regarding the gap here, I am going to put some tape, as I said. The material tape. So I've cut some here, and I'm going to bend part of it forward. So I folded that. So I folded part of the tape over. As you can see. And I will be sticking the bottom part where I folded onto the bottom here, and that would reduce the gap. But what I'm going to do is, to make sure it will not come off, is I'm going to put some extra glue, adhesive, onto the tape, and maybe around here. So I'll probably put the glue there off camera, and then I'll stick it on. Okay, so I stuck the material tape, and I didn't rely on its glue. I just added just contact adhesive, and so just to cover the gap. So it's not over the hub, it's just exactly where the hub finishes. So spin it. Okay, so I'm covering that gap just to stop any dust or flour and, you know, getting into the hub section where the grease is. And it's just still going to have the cover here, and that will cover that section also. Okay. What I've just left to do here is to put the bottom felt on. Just aligning where the screws have to go. Okay. So now I can put the cover on. Screws. Actually, I believe that felt is to cut the sound of the gearbox, the noise. That's what I probably believe that it's for. What's wrong with the screw? Okay. Okay, we'll put the front cover on. Okay, let's just try it on. Well, I think it does sound a bit more quieter actually. Maximum. Minimum. My circuit breaker just tripped there on the variant. See? If I go quickly, it draws a lot of current. It's set at 1.3, so let me set the current to, let's go to 1.5, just to show you. Let's see if you'll be able to see that. So I've got the current 1.5. Okay, back to the machine here. See if I go full speed. Doesn't trip. Anyway, I made a mistake when I was talking about the rating at some other videos of the machine. It's rated at 1.4 amps. So yeah, that was stripping. I had it set it to 1.3. It does sound a lot quieter. Amazing. That special material, that felt, does make a difference. and having the cover here, it does cut a lot of noise of the gearbox. It seems to be working very good. You can see here now when that's going around. I'll try to bring up the other video, or the first video, how it's going like that. So at full RPM, going 0.85, close to 0.85. Okay, so all that's left to do now is to put the rubber feet when I receive them. Because I haven't got those. Alright, the final touch to this, the plate that I made for the missing part, the steel. I put a bit of double-sided tape here, and I just printed a sticker and stuck it on there. So that's the end of the project. So I hope you enjoyed the videos.